We've got our next panelist ready. Our next panelist and our final panelist for today is Minko Gechev. Minko is the technical lead and manager of the Angular Dev Relations team at Google, and he's going to be sharing some wisdom around predictive prefetching for the web. Welcome to the show, Minko.
Hello, glad to be here. Let me share my screen and we can get started.
Awesome.
Okay. I assume you see my slides, right?
Yes.
Perfect. So yeah, hello everyone. My name is Minko Gechev. I'm working on Angular at Google, where I'm leading the developer relations team. Today, I'll be talking about how we can implement a predictive prefetching strategy when building web applications. So in this presentation, first, we're going to focus on what performance issues actually prefetching is solving. We're going to discuss a couple of different prefetching strategies with their pros and cons. We're going to talk about lazy loading and how it relates to prefetching. We'll look into a particular implementation called GuessJS. And right after that, briefly, I'm going to share with you about a research that we did with the TensorFlow team on more sophisticated machine learning predictive prefetching pipeline. So web applications are generally pretty slow. About 77% of mobile sites take more than 10 seconds to load over a 3G network. And the average load time of a mobile website over a 3G network is 19 seconds. This data is a little bit slow, but unfortunately things haven't changed too much. So as you can imagine, people will be pretty frustrated opening a website that takes 19 seconds to load. They will not be only frustrated, but also stressed out. So it looks like in order to wait for a slow web application to load, this would be almost as stressful as watching a horror movie. And some resources on the web are more expensive than others. JavaScript and JPG image, for instance. JavaScript and JPG, they both need to be decompressed, right? However, JavaScript right after that needs to be parsed, needs to go through different phases of parsing by the JavaScript virtual machine, and after that needs to be compiled and executed. All these phases take way longer compared to the processing of a JPG image of the same size. This has changed over the past couple of years a little bit. So JavaScript is a little bit faster to parse. The V8 team did a lot of work into optimizing their parser, and also there are different ways to implement stream parsing. So the moment we start downloading a particular JavaScript, we can already start parsing it as well. However, JavaScript is still the most expensive resource that we ship to our users. And we need to be careful how much JavaScript we're shipping. We need to make sure that we're shipping only the JavaScript that the users actually are using. Lazy loading is a technique that can help us with this. We can just delay the JavaScript that is associated with functionalities that are not yet needed by the user, that will be needed in the future. And based on different heuristics, we can download exactly the JavaScript that the users need. There are generally two high-level heuristics. We can either apply component-level code splitting or route-level code splitting. We can put the component-level code splitting into the context of, let's say, an e-commerce platform. Let's say we're building something with a chat widget, an e-commerce platform with a chat widget, where the chat widget is pretty complicated. It's something like Slack running in the browser. And only, let's say, 2% of users engage with this widget. You really don't need to download it the moment the user starts request our page, right? Because the chances are that they're not going to use it at all. What we can do instead is show a proxy, just DOM element. And when the user engages with this DOM element, we can download the bundle, the JavaScript bundle associated with this chat widget, and we can bootstrap it in the browser. This is component level code splitting. Today, we're primarily going to focus on route level code splitting. In route level code splitting, what happens there is that we are splitting the individual pages per route level. So we're not going to download all the different pages when the user opens the first page of our application. Rather, we're going to delay. So when the user navigates to the settings page here, for instance, you can see in Chrome DevTools how we're downloading the JavaScript associated with the settings page, and right after that, it is rendering it. Once we process it and the JavaScript virtual machine goes through parsing, compilation, and finally execution. This works great with good network conditions. However, when the network conditions are not as impressive, this could lead to certain delays. Notice here how when I click on the settings page, it takes me a couple of seconds to see it. This is because I introduced some extra throttling, which tries to emulate a poor mobile network. So when I click on settings, it takes me a couple of seconds. It takes a couple of seconds of the browser to get this JavaScript. And from there, it still needs to go through parsing, compilation, and execution. And this is a suboptimal user experience. We don't want the users, when they click on the page, to have to wait for a couple of seconds to see a result. That's pretty much the promise of single page applications, right? That they wouldn't have to do that. We can improve this user experience by using a technique called prefetching. I bet most of you are probably familiar with it, but let me make a very quick recap. So prefetching is a technique that allows us to fetch some resources over the network that the user is likely to use in the future. This way, when we prefetch these resources and we put them in the cache, when the user needs them, the browser wouldn't have to go to the network to fetch them. Rather than going to the network, we'll be able to get them directly from the local cache. However, there are a couple of risks with prefetching. We can consume a lot of data. Imagine that we implement a very aggressive prefetching strategy where we download all the different resources of the page right when the user visits the page for the first time. This might be too aggressive, and we may consume a lot of data, which is still expensive on mobile. Every month, when I'm consuming more data, I'm paying more to my mobile provider. So I would ideally prefer to pay less. And if we want to be considerate for our users, would ideally prefetch fewer resources so that we consume less data for them. Also, we may never even prefetch the resources that the user would need in the future. So our heuristic may provide inaccurate results. And there are different heuristics for prefetching data and prefetching JavaScript in this particular case. For example, as I mentioned, we can prefetch everything. We can use a quick link prefetching strategy where we're prefetching everything that is visible on the page right now, meaning all the links that are visible on the page, we're going to prefetch the associated pages. We can prefetch on hover, or we can use predictive prefetching. Predictive prefetching has a slightly more complicated setup time, but at the same time provides way more accurate results. Let us dig into this solution now and tell you more about what predictive prefetching actually is. So let us look into this Wikipedia-like application. We can see that on the page here, we have links that are highlighted in different color. For example, we have red, purple, and blue. The links that are very likely to be visited next, based on some statistics of the website, are highlighted in red. The ones highlighted in purple are mildly likely to be visited, and the ones highlighted in blue are unlikely. So what we could do on theory with predictive prefetching is to prefetch only the links that are very likely to be visited next. This way, we're going to have certain level of confidence that we're going to have the links that the users are eventually going to need, or the pages that the users are going to need, cached before they actually attempt to visit them. This is a prefetching strategy implemented by the tool Guess.js, and I'll tell you more how Guess.js actually works. Guess.js uses information from Google Analytics. So if you have Google Analytics, you can already take advantage of Guess.js. Basically, Guess is going to request all the previous pages for all your current pages. This means that we can build a page navigation graph similar to this one right here. Notice how we have stronger connection between some of the nodes and weaker connection between others. This means that the nodes that are likely to be visited one after another have stronger connection or thicker edge, and the ones that are unlikely have a linear, like a way more narrow edge between them. But here from Google Analytics, we're getting information for individual pages. We're not getting information about JavaScript and how one JavaScript bundle is going to be used after another. How do we map this to JavaScript? Well, we can use techniques from static code analysis. So if we look at this Angular routes declaration, where we're using slightly legacy syntax for low children, just for simplicity reasons to keep it short on the slide, we can map this to the actual page navigation graph that we got from Google Analytics. We can assume that we have 3 pages, let's say, A1, A2, and B. And the user is very likely to go from A1 to A2, very unlikely to go from A1 to B, and very likely to go from B to A1. So what we could do is perform static code analysis. We can see that we have 2 routes declarations. We have A with a particular ID, and we know that this is associated with the bundle that has entry point a.js. We also have the route B that is associated with the bundle with entry point b.js. So what we could do is map this bundle world to the page navigation graph. Get.js does this at build time. So at build time, it is going to analyze the entire application. It is going to figure out all the different routes within this application, and it is going to map them to pages that we got from Google Analytics. And it is also going to work for some special use cases. For example, here, Get.js is going to understand that the bundle with entry point a.js is associated with all the different A routes. So if we see an A.A/1 or A/2 or something like that in our Google Analytics report, we're going to map all these pages to this particular bundle. Get.js also performs a partial evaluation. So if it finds that a particular entry point is in fact an expression rather than just being a simple literal, it is going to try to evaluate this expression as much as it can at build time. All right, so for each module, we pretty much need to find all the path declarations. And by module, I mean pretty much a JavaScript module, a JavaScript file in this particular case. And from there, we can map it to a particular bundle. Here is another example. So we have main.ts, and in main.ts, we have declared a couple of routes, A, B, and C. And the A route is associated with the A.ts page, the B route is associated with the B.ts, and C with C.ts. Eventually, these could end up in different chunks. Once we build the application, the A.ts and B.ts could end up in 1.chunk.js, and C.ts could end up in 2.chunk.js. So generally, the graph that we're going to end up with is going to look similar to this one right here. We'll know that the user can go from the 0th chunk to the 1 chunk, and from the 0th chunk to the 2 chunk. So that's pretty much the entire knowledge that we need at this phase. In the next phase, Get.js is going to build a model. And this model could be either a very simple Markov chain or a neural network. We're going to briefly discuss how this would look like with a neural network in a little bit. So Markov chain. If you're not familiar with what Markov chains are, well, you can think about them just as matrices. We're going to look into a particular example of a Markov chain. But the interesting thing about Markov chains here is that they allow us to predict the future to a certain level. Based on the current state or based on previous events, we can predict what is going to happen next. It is just a matrix that shows the probability for a certain event to happen. Let me show you what exactly happens at runtime, and this is going to give you way better understanding of how Get.js works and how these different things actually fit well together. All right, so let's suppose we have this page navigation graph. From Google Analytics, we know that we have, how many pages are here? Like 6 pages. And we know what is the probability for the user to go from one page after another. After that, at build time, we have figured out that the individual pages are associated with 3 different JavaScript bundles. We have the red group, so all the A pages are associated with only a single JavaScript bundle. All the B pages are associated with a separate, we can call it a yellow JavaScript bundle. And we also have the root, which is a separate JavaScript bundle as well. What is going to happen next is that GetJS is going to detect on what is the network speed of the user. In this case, it is going to detect that the network speed is 3G. So we're going to set a prefetching probability threshold, meaning that we're going to prefetch only JavaScript bundles that are likely to be needed and have a probability to be needed higher than this threshold. So this means that we're not going to prefetch any JavaScript that has lower probability than 0.5. And we also have this matrix right here, which is the actual Markov chain. So that's what Markov chain actually is. You can see that we have a 0.3 probability for the user to go from the root page right here, which is the first row, to /A. And we have 0.7 probability for the user to go from the root page to /B. That's pretty much how Markov chains work. Now, taking the probability threshold in this matrix, we're going to try to predict what the user is going to need next so that we can prefetch it ahead of time. All right, first, the user is in the root page, in /. We're going to look at the corresponding row of the matrix, and we're going to see that there is only a single route that has this probability to be needed next, which is /B. This means that we're going to download the associated bundle, b.js. After that, we're going to take a look at /B, because let's say that we made an accurate prediction and the user is actually in /B. At this point, we're going to look in the Markov chain, and we're going to find that the next page that is likely to be needed next is /B/A. This is, however, in the same bundle though. It is in the yellow bundle right here, so we're not going to perform an action. When we go to /B/A, we're going to look at the corresponding row of the Markov chain and download the A bundle. And that is pretty much how GetJS works. There are a couple of very minor details, and I'm going to mention one of them in a little bit. But before that, let us make a very brief overview of the entire pipeline. So what happens is, first, we're fetching data from Google Analytics. Right after that, we're mapping this data to JavaScript, because there might not be one-to-one mapping between a page and a JavaScript bundle that we want to prefetch. Right after that, we're building the Markov chain. We're embedding the runtime of GetJS, which is just a tiny bit of JavaScript, which tracks which pages we're visiting, and the Markov chain in the JavaScript of the browser, of the application, excuse me. And from there at runtime, we're prefetching the pages that are likely to be needed next. But does this mean that we need to prefetch the entire model? Well, actually, no. Let me show you what pieces of JavaScript we're embedding in the user application. So first, in the main bundle of the app, we only need the prefetching functionality. This prefetching functionality tracks the user's navigations and also makes sure that there is high enough probability for the user to follow certain navigation in order for us to prefetch some JavaScript. What happens in the individual JavaScript bundles is that we have prefetching instructions. So for example, in the A bundle, we would know that there is the bundle B next, and there is 0.3, there is a 30% chance probability for the user to need this bundle. So we directly call the prefetching functionality. That's how this works. And this is kind of a, let's say, ahead of time predictive prefetching to a certain level. All right, so we talked only about JavaScript. What about other assets? Well, other assets are a little bit trickier. GetJS here assumes that we have static knowledge for the resources that we would want to prefetch. And in the web, many resources are downloaded in a very dynamic way. For example, the user interaction may cause us to assemble a dynamic URL that we'll need to download, and this may not be statically analyzable. So a couple of different ways for us to discover assets is dynamically by traversing the application with a headless browser, or statically if we trace Webpack imports, which, however, is not a complete approach because of the dynamic scenarios that I just described. At the very beginning of the talk, I also mentioned that there is a neural network approach of predictive prefetching. So with the TensorFlow.js team, we worked on a pipeline that allows you to pass your Google Analytics data to BigQuery and consume it with TFX, with TensorFlow Extended, in order to produce a TensorFlow model that you can use in your JavaScript application within a service worker. You can find more about this approach in this talk that we gave together with Dave from TensorFlow on Google I/O. And also here are a couple of resources that might be helpful for you, including predictive prefetching, guess.js, and predictive prefetching with a neural network. And I would really appreciate your feedback for the talk. So please take a moment to fill the mgv.io/talk survey. I would really appreciate it. And yes, I would love to answer any questions you have about predictive prefetching or about Angular, since that's what I'm working on.
All right. That was an interesting conversation. Thank you, Minko. We see questions coming in from the audience. The first question that I see is from Raj Maharjan, who asks, would the pages to be prefetched load in background or with the page?
Yeah, they're loaded in background. So what is happening is guess.js is creating a link rel prefetch, and it instantiates this element within request idle callback. So everything is happening with kind of very low priority in a way that it is not going to consume computational resources from the page.
Okay, so because if we do next page to be loaded with the current page, if it is prefetched to be loaded, wouldn't the current page load slower?
Yeah, exactly. It will load slower. That's why guess.js is waiting for the current page to load, and with low priority, it is adding the prefetch element, the link prefetch element.
Okay. I see another question coming in from Madhav, who asks, if the pages need extra authentication, what strategies are used?
Yeah, that's a really good point. With authentication, things could be, well, it depends first though. The JavaScript if the JavaScript associated with these pages requiring authentication contains some sensitive data, then that's probably not a great idea already, because these resources are already discoverable they could be discoverable by looking at the Webpack configuration of the page. So I would just recommend not keeping sensitive information in the JavaScript, because that's going to be a big security risk. If, however, on some other reason you prefer to not prefetch particular pages, there is in guess.js, let's say, there is a way for the developer to specify which pages they don't want to be prefetched. And if you're implementing a custom prefetching strategy with a service worker, similar to the one we discussed here with David, yeah, this is still very much possible, as it involves manual logic though.
Okay, awesome. If anyone else has any other questions for Minko regarding JS or Angular, please feel free to drop them on the chat. I have one question for you, Minko. When a new page is added to the application, by default, there might not be prefetching for the page because of analytics. Is there a way to explicitly add routes to the predictive engine?
Yeah, that's a really good point. Yeah, when there is no statistics for this page in Google Analytics, there is no way for Guest.js to know that it needs to prefetch this page at all. Yeah, I would recommend just like if it is critical for you to implement prefetching for this particular page, an explicit link tag, explicit logic could be an alternative, or waiting for a couple of days, for like 2-3 days, for the users to have visited this page so that you can consume the Google Analytics report for the past 3 days, which means something like continuous deployment. With continuous delivery, every time when you deploy the application, you would consume the latest information from Google Analytics. So this delay of a couple of days might not be critical for the users if this page is not being prefetched in the meantime. That's what I mean.
Yeah, especially if it's a new page. I mean, they might not have enough to pull data from. All right, I see one more question just popped in the chat. Intro about future-proof web apps.
Well, the intro, I would recommend to just to check out the talk. I can give you the gist of what we're talking about there, though. There are two main experiments that we discussed. One of them is NGX TFJS, which is Angular bindings for TensorFlow, or TensorFlow bindings for Angular, which allows to use different TensorFlow models directly in your Angular templates. It's pretty easy to integrate TensorFlow with Angular. And the second part is discussing this predictive prefetching pipeline, which you can also find right here in mgvio/predictive neural network. It's a way more advanced topic, but it's also fun to explore.
Awesome. Ajul, if you want, you can go ahead and put that in your browser and take a look and come back with more questions. I see another question from Sanjeev, who asks, can you tell me at what point of time is the model for prefetching is actually inferenced? Is this done by some scheduler task?
Yeah, on each navigation, we're running, it is pretty much scheduled with requests idle callback. So on each page navigation, we're scheduling this with very low priority. So it goes somewhere in the browser queue, and the browser invokes the prefetching logic whenever it has a free moment, so that we don't cause frame drops.
Interesting.
And with the predictive prefetching for future-proof web apps that we discussed with David here, it happens in a similar way, but the prefetching, the mechanism there is that the prefetching is in fact in a service worker. So the main page still uses request idle callback in order to send a message to the service worker, which prefetches the page. And since the service worker is running in a different process, this doesn't have any implications on the page, on the how heavy on the frame drop, on the frame rate, let's say.
Thank you. I see one more question. Anvesh asks, what happens if we need to change some route /a to a new route /neva? Do we need to wait for analytics to generate new Markov chain for /neva, or we can use the previous data for /a route?
You can do either. Yeah. What happens with, so Guest.js provides an API that allows to map a particular page name to another. This is a hook that Guest allows only because we don't have guarantees that the extraction of the pages and the mapping to individual JavaScript bundles is going to be too accurate. I mean, in the general case it is, but there are some cases when developers need to add some custom logic. So yeah, using this route mapper would be the way to go. Just a disclaimer for Guest.js, the primary purpose of me talking about this tool here was to show you how this works. Currently, Guest.js doesn't function with Webpack version 5. And also, it works really well with Angular. It works well with Next.js, and works well also with Gatsby. But just keep that in mind.
I hope that answered your question, Anvesh. I saw somebody's hand raise while we were talking. So if you have a question, please DM me, or you can let us know. I see another question from Raj, who asks, would research on this topic be possible for an undergrad student, since collection of data collection is the hardest part as per projects he's done?
Yeah, I guess it depends on what part of the problem you focus on. There are a few different things here. First, the actual mapping of pages to the static resources. This is a pretty interesting topic by itself. It involves some static analysis and partial evaluation. If you focus on the accuracy of the models and compare different approaches and their accuracy, it might be a little bit tough, exactly because of the problem you mentioned, collection of data, like having rich data set. Just discussing novel approaches for prefetching, I think that's a pretty reasonable undergrad project.
All right. Do we have any more questions from the audience? Okay, they're coming in now. Here's one from Shrishan. Do you see parallels between what you're talking about and with CPU branch prediction plus hardware prefetching?
I mean, the prefetching part, there are some parallels for sure. And I'm not too familiar with CPU branch prediction, so I would not be able to dig deeper into that.
Okay. The next question is it possible to add such auto-fetching through plugins and stuffs like WordPress to auto-fetch contents on e-commerce?
Yeah, there is. Well, for Gechev particularly, no. Although I think this might be a good opportunity to implement predictive prefetching. I'm pretty sure that, yeah, that's a good opportunity. So that's maybe something worth looking into. Currently, there is a popular WordPress plugin. I'm, let's say, 90% sure about this because I didn't work on this plugin directly, called QuickLink, which allows to prefetch all the pages that are associated with links that are currently visible on the page. I would recommend you having a look at this. It's developed by the Chrome team.
Okay, awesome. Let us know if you find anything though, Abhishek. The next question that we have is from Poojan, who asks, is there any other prediction model other than Markov chaining that you think better works for fetching right resources?
So yeah, Markov chain would be a good approach. I think Markov chain is actually the optimal approach for most use cases because it is a very small model. You don't have to ship an entire deep neural network with many layers and a runtime to execute this neural network. So Markov chain provides an all right accuracy. It's not the most accurate approach, but it is decent and doesn't increase the bundle size of the page too much because it is not very reasonable to implement prefetching where the model is 5 megabytes, let's say, and this blows the page significantly, executing in a main thread. So that is why I did a lot of thinking about that, and Markov chain seems like the right approach, especially if the model is running in the main UI thread. Another approach would be with the deep neural network that we're using in this example right here with future-proof web applications, and maybe even a more accurate one would be with using like a recurrent neural network, which is based on like some time series. The time series will be the sequence of pages that the user have navigated through in order to go to a particular page. This is going to bring some extra accuracy. And also, there are many other different features that we can look into. The navigation history is one, but we can also have a look at other metrics like where the user is from, let's say, or we can look into some specific session ID of the user, or in order to make to implement some more personalized prefetching. There are a lot of opportunities, and I would say that they're mostly application specific at the same time.
All right. I see another question that just came in. Is it possible to refine the chain in real time, considering the behavior of the end user?
Yeah, theoretically, it's possible. Oh, I see what you mean. Yeah, I guess there are two aspects of this one. The first one is can we update the statistics at real time if it has been updated significantly from Google Analytics without redeploying the app. And the other one is refine in real time, as you mentioned. Yeah, with a more advanced model, we can keep track of the navigation history, and the model could be smart enough to consider the different features that we would want to take into consideration. So yeah, it's theoretically it's possible. This is something that you can explore with in the future-proof web apps use case.
Awesome. So we do have some time for more questions if anybody's got them, or if anybody went to the resources that Minko has shared and dug up any more questions. We're here for a bit more to answer any of them.
Really, really good questions. Just very fantastic questions. Thank you very much for asking them.
It's making you think. If not, I think we're looking good to close the audience for today. If nobody's got any more questions, I think you've... Okay. Here's one from Sujan. Angular or React, and why Angular?
Yeah, I'm getting this question often. So, I mean, you can pick either, and I'm sure you'll be successful with React or Angular. It doesn't, like both could provide similar functionality when you're building specific types of applications. In Angular, we're trying to provide the entire platform rather than primitives for developing components. So together with Angular from the Google team, we're also developing not only the framework, but also a CLI, which is pretty powerful. It has functionalities from anything from code generation to deployment, and also a component kit. So we have Angular components and the Angular CDK, which allows development of accessible applications. We have a lot of utilities there for accessibility. We have heavily invested in the good integration between these tools. So these are some of the goals and some of the values of the Angular platform. Another thing is that we are like very heavily invested in best practices. So if you're using Angular, you're coming from the very beginning with TypeScript, which means static typing. This is something that we truly believe is a good practice, since it helps you catch a lot of the issues in your code ahead of time because of the type system. And there are many other such best practices as well that we have discovered and embedded into the tooling. You can have a look at them at angular.io/style guides. So that's why I like Angular. That's why I've been on the team for that long and part of the community for the past about 10 years now, maybe 9 years.
Awesome. Okay. So I see another question that just came in, and it states, while we are talking about Angular and React, what are your views on Polymer.js?
I would have strong opinion about Polymer.js. I know that the team that was heavily working on Polymer now is also investing in Lit. So these are all interesting solutions. And yeah, I don't have enough context there to make a good comparison. And also, I'll be clearly biased. I'm working on Angular, so I like Angular.
Awesome. Next question is from Alexi, and she asks, or he, I'm not entirely sure. I see many developers try frameworks before learning the vanilla JS. As an avid JS programmer yourself, what would you suggest?
Yeah, having good understanding of JavaScript may make things simpler, for sure, in order to have solid foundation. And here things are going to look like magic when folks start learning particular framework. So the framework is adding just some constructs on top of, based on the language, meaning that if you have already a solid foundation in JavaScript, you'll be able to easier pick the individual concepts and use them. So I would recommend having familiarity with JavaScript first. Maybe folks don't have to be experts and know the standard by heart, but having good understanding of JavaScript and the event loop and the syntax for sure is pretty important.
Syntax. All right, I see a next question come up that states, what is the support for Guest.js for module bundlers other than Webpack?
No support for any other bundlers than Webpack. That's it. Webpack version 4, and I think version 3 as well.
Oh, well, there you go, Prajal. There's nothing else. You just got to stick with Webpack. Any other questions from the audience while we still have Minko? All right. Why only Markov model and neural network for predictive part? Question mark.
Yeah, these are the models we have explored. Maybe there are opportunities with other models that we just haven't looked into. The Markov model seems like a good fit, and I'm pretty sure it's pretty optimal. Maybe not the most optimal fit, but it provides good trade-offs. And neural networks were an interesting area to explore, and also a good fit for, let's say, e-commerce web applications. That's where we think they fit really well.
Awesome. Anyone else? Any other questions for Minko? Going once, going twice. Okay, here we have two more. Okay. People really like a ticking time bomb. Being a dev, what is it that makes you continue the thing you are doing? That's a deep question.
Yeah, I like it. I like it. Very existential. And I think I need to think more about this to give you a very accurate answer. The two things that come up to my mind are building something challenging and something innovative, something that I have never built before, and maybe nobody has, and the community part of it also. I would not be as motivated to build this thing in isolation. I really like to see how this impacts developers' lives, and from there transitively their users' lives as well. So I guess the impact that my work has, this is what has been motivating me the most.
Awesome. All right. I think that spiraled a lot of people into asking you more developer questions. So here's one. When is the support for Webpack 5 in Guest.js coming? My hands are itching to test it in an enterprise application.
So I haven't planned implementing Webpack version 5 support so far. Guest.js, its adoption is not super high right now, so it is a trade-off that I'm not sure I want to take right now. It's going to take me probably about a week or two to implement Webpack version 5 support and test it well, and I'm not sure how much, about the return. I'm not sure how much this would increase the adoption of the tool. So if there are enough people who are really excited about Webpack version support in Guest.js, I'll be happy to invest a couple of weekends into this. But alternatively, I'm planning to just keep version 4 support for now.
So if you're really keen, go tweet at him saying you want it. All right, the next question is there any support for analytics service other than Google Analytics?
Yeah, there is a hook that allows you to specify a custom analytics source. So there is a hook called, I think, report provider, that is just an asynchronous function which takes data from somewhere and returns data in a specified format. And the format is specified by a TypeScript interface, so it allows consistency.
Okay, next question that we have is, what kind of neural network are being experimented at the moment? Does it have anything to do with sequential models and RNN?
Yeah, I don't think it is, unfortunately. Yeah, I think it is the model from this talk. I think it is just a deep neural network. You can have a look in the model and the TensorFlow organization. There is a TensorFlow.js examples repository. You can find a dummy model there that you can explore more. It's just a deep neural network.
Okay. Jagjit looks sad that he has to downgrade to Webpack 4, but I'm pretty sure he'll survive. Be sure to go tweet at Minko and ask your dev friends to tweet at him too.
Yeah.
The next question that we have is, how do you see the future of machine learning driven user experiences in the web?
Yeah, that's a good question. For sure, there are going to be more and more applications. I see how this could help with how machine learning could help with accessibility, with the models getting more and more accurate and the hardware improving. For example, there were a couple of experiments where folks were interacting with a web application without their mouse and keyboard, just let's see by looking at the page. And there was eye tracking that was trying to predict where they're going, not trying to predict, but recognizing where they're looking at so that the page can decide whether it needs to scroll itself or press a particular button. I see this as a good, like really fantastic application. I don't think we're there yet with the accuracy of these models. It might be a little bit more frustrating experience than useful, but that's probably that's hopefully going to be more accurate and possible in the future. I also see a lot of applications around, like prefetching is clearly one of them, as we discussed in this talk, and probably other user experience related features, maybe depending on, yeah, just user experience related features, like let's say from theming to customized layout of the page. I'm not sure how this is going to look like though, but there are interesting ideas to experiment with.
You look really curious about it. I freaked when you said, when where the eye moves on the screen. All right. So the last question that we have for you this morning is, as React's knowledge can be translated to React Native for mobile app development, is there a plan for Angular to take that path for mobile app development as well?
So in Angular, we're primarily invest in cross-platform web applications. If you'd want to develop a mobile app with Angular as a framework, just without any of the third-party tools that are currently being offered, you can build a PAA. However, there are many tools that are developed by companies and individuals that allow you to build mobile web applications. Like there is Ionic. They're providing good opportunity for hybrid web applications there. And there is NativeScript, which is somehow comparable to React Native. I think they have different mechanics on how they're running things, mostly around the DOM reconciliation, because we don't really need reconciliation in Angular, but it is kind of the Angular solution for building truly native mobile applications with Angular. And there is also Capacitor by Ionic as well, which is something in between NativeScript and Ionic itself. So these are the four solutions: PAAs, Ionic, Capacitor, and also NativeScript.
Awesome. So this is going to be our last questions. I'm just going to ask the one question from Sagar that just popped in. And he thanks you for the talk. And his question is regarding the JS web frameworks and Flutter web. How do you see Flutter web competing in all the web frameworks that are available right now? Will it be able to survive since Flutter web is stable now?
Yeah, so there is often the assumption that when a new web technology is released, it focuses all the different use cases for building web applications, and that's not always the case. That's often the case, but not always. So I also can't comment on the Flutter web strategy because I'm working closely with the Flutter team, but I'm not part of their team. So I can tell you what my recommendation would be, and this may not align with what they believe in. So take this as a disclaimer. Flutter web is great when you have a native application, native mobile application for iOS and Android, and you want to, based on this application, to create a web app as well. And Flutter web will do that for you perfectly. There are some trade-offs there around the compilation of the application and the Dart runtime. This adds up to the JavaScript bundle. So if performance is not critical, Flutter web will work great. And I don't think Flutter web is at risk. It's just a great way for you to have a web application if you have functioning mobile applications as well. I don't think any of the frameworks right now is at risk because of Flutter web either. So everything could coexist.
That sounds harmonious. So we're at the top of the hour, but I see a few questions pop in. Do you have time to answer the last question
Sure,
that
yeah.
came? Okay,
Yeah.
so the question is, what kind of future can we expect for Dart on the web, specifically Angular application written in Dart?
Well, I can't comment on this, unfortunately, because I'm not part of the Dart team. So I don't know. I know that the Angular Dart recommendation. So Angular, that's one clarification. Angular and Angular Dart are two completely different frameworks right now, and they're developed by different teams. And we even don't have enough intersection between our work to have to talk frequently with one another. Based on my understanding right now, that the Angular Dart team is recommending transition to Flutter Web. I don't see any development in the space, and I don't think there is anything planned on improving the development experience of building Angular applications with Dart. Angular generally is a TypeScript framework, and that's how we're going to stay.
Okay, yeah. Awesome. I think you killed a lot of people's curiosity and their hopes for Webpack 5 as well today. But hopefully with enough tweets, I think it may have already started. Hopefully. Yeah, well, thank you, Minko. I hope you had a good time. A lot of us had a good time hearing you talk. That was Minko Gechev, lead developers relations lead at Google. You can reach him at
Gechev, MGECHEV, on Twitter, GitHub, LinkedIn, all the places. And thank you very much for joining. It was great pleasure. We had fantastic questions. I'm really happy. I hope I helped with answering and fulfilling your curiosity.
Awesome. Thank you. We had fun talking to you. All right. So that concludes Syntax Day 1. Thank you, everybody, for joining and staying in till the very end. Come back tomorrow for Day 2 to hear our second lineup of panelists talk about cloud native application, chatbots, and our lightning speakers, and a lot more. See you all tomorrow at the same time. Thank you. Bye-bye.